Question number 40, the last question. A sector which subtends an angle of 72 degrees at the center of a circle of radius 8 meters is turned into a cone. The vertical height of the cone is, now this is a sector. Let's sketch a sector. Okay. This is the sector. Okay. And then okay, let's permit my drawing. Okay. So radius it's 8 meters. So here is 8 meters. Subtends an angle of 72 degrees. 72 degrees. This is the shape. This is the shape called a sector. Okay, it's turned into a cone. Now, if you turn this into a cone, if you turn this into a cone, and then that's when you turn it into a cone, that means you have folded it. And then you have the center here. You have a new radius here, small r. And then we are looking for the height, h. So then I say the vertical height of the cone. This is now a cone. When you pick a sector and then you fold it and then you turn it to a cone. So this place remains our 8 meters. So, and our angle is still 72 degrees. So we are being asked to find the height. How do we do that? Now, remember, so now for this sector here, the length of this arc, this is an arc. The length of this arc is calculated as what? Theta over 360 times what? 2 pi r. R, this one. Then you see when you now turn it to a cone, you have formed a circle beneath it. And the circumference of this circle, when you say circumference, that's total distance, the length of the distance around the circle, is given as the circumference is given as 2 pi r. You understand that? So now it is when you use this sector and turn it to a cone, it is this length of this arc that you have finally turned it to become what? A circle at the bottom. So in that regard, what am I saying? What am I driving at? I'm trying to say that the length of this arc is the same as the circumference of this circle. So here is what? The length of the arc. And here is what? The circumference. So the length of the arc equals to what? The circumference. So we equate these two things. And remember, what is our theta? Theta is 72. 72 over 360 times 2 pi big R, that's 8 here. 2 pi times what? 8 must be equals to what? 2 pi r. 2 pi r. We don't know what the small r is. So from here, 2 pi will cancel 2 pi. And then your r will be equals to 72 over 360 times 8. If you do that, it should give you 1.6 or so. 72 divided by 360 times 8 will give you 1.6. So now we know what our R is. So if you draw out this now there's a right angle triangle inside this cone. So if you draw it out, okay, permit me. If you draw that right angle triangle out, okay, so successfully drawn it out, you now find out the radius, which is this bottom, is now 1.6. And then this slant height, the fullest slant height is what? 8. And then here remains the height. So what comes to mind now is Pythagoras theorem. So now to find the height, that would be height squared. See, this is the hypotenuse and this is the adjacent. So this will be, the height will be hypotenuse squared minus the adjacent squared, 1.6 squared. So this will be 64 minus 1.6. That's 2.56. If you subtract the 2, to give you, it will give you 61.44. That's h squared equals to 61.44. So therefore your h will be square root of that, square root of 61.44. And your square root of 61.44 will give you 7.6. So therefore, your h equals to what? 7.6 meters. All right.